Hi, I'm Davor Stjelja. I'm coming from Croatia. I'm a PhD student at Aalto-universitetet on the topic of utilizing the building operations data with machine learning in a scalable way in order to enable smart buildings. So, main motivation comes from the fact that buildings are responsible for about 40% CO2 emissions in the world, and I'm focusing on the building operations phase. And the most thing that we can do there is either to optimize energy consumption or space utilization of those buildings, so the total CO2 emissions from building sector would be reduced. Another motivation comes from the thing that buildings are getting more and more high-tech. That means that there's a larger amount of sensors, more and more things that you can control in the buildings, and therefore also the amount of data that is produced in those buildings is getting larger. Even though we like to call those buildings smart buildings, but they are often not. Usually the data is used only for one thing or one purpose only, and it's not utilized as it could be. And I'm trying to solve that problem. Also, one key driver of my work is the rise of AI technology. For example, current situation in a modern building, for example in a meeting room, you often have a CO2 sensor which is controlling a ventilation system, variable airflow ventilation system, which basically when the CO2 in the room is too high, it increases the airflow and also decreases. And that data from that CO2 sensor is usually used only for that purpose and not any other. So my idea how a real smart building should look like, that from that same data you could utilize it throughout many different domains, and it can be enriched together with the machine learning. So for example, occupants can see free space, because from CO2 information and machine learning you can also find the information of the occupancy. So also when we aggregate that data throughout the time, we can see that our asset manager can utilize that data to see how the space is used over the time. As I mentioned before, HVAC system can use for controlling the ventilation, or if we see any anomalies, we can see we can report it to the maintenance person. And one good thing that it can be used for example, for human resources, if we are tracking the number of people in meeting room and how often are the meetings, they can use that information to follow the trends of the organization which is using that building. So this is just an example of how smart building could work, and I'm going step by step to that direction. So my first step was my first paper published in December 2020, where I tried to get information on office occupancy using the electricity and water consumption data from a building. I used their machine learning, two approaches, supervised and unsupervised data mining approach. And to explain those further, supervised machine learning is when you have a training data to train the model which will perform certain tasks. In this case, to detect occupancy, you need to first know the ground truth or actual occupancy, and then also take the consumption data from that same time to train the model, so that in future you can use only the raw consumption data in that model to tell you the number of people in a building, which is a problem to get that occupancy data as the first place, but that method gives a higher accuracy, which I'll show in next slide. On the other hand, I wanted to try a simpler method, and what can I get with that? Simpler unsupervised machine learning doesn't need a training data, so you only use a raw consumption data like electricity, water consumption, and then the data is clustered into several clusters, and the resolution of the output is that way lower, which you will see in a second. So for example, from supervised method, one can get hourly consumption, how many people are in a building. In this graph you can see the actual occupancy and predicted with the model, that they're pretty close to each other. And then with the unsupervised method, instead of getting hourly occupancy, I was able to classify days by their occupancy using the consumption data. So for example, I got one class of where occupancy is almost zero. That's usually on public holidays. Then I got one when there's normal amount of people in an office, which is a normal working day. And then the third class was something in between, which are, I call them semi-holidays, usually days when people often take vacation, but not everyone in the office, or maybe if the public holiday is on Thursday, people take a Friday off and things like that. So you could see that with this unsupervised method, I cannot get like the actual number of people, which I can with supervised. But then again, I don't need that much amount of training data. So therefore, in my second paper, I tried to use the supervised method, but to reduce the amount of that training data. So I'm currently working on this paper where a bit use case is different. I'm trying to use CO2 sensor data from a meeting room to estimate the occupancy of that meeting room. And as I mentioned before, for a supervised model, you need a lot of data, including the ground truth, to train the model so you can use it. And I'm using a transfer learning approach where basically we train a model on one building, on one room, which has a lot of data, and then we try to scale that, to apply that model in a completely different building, in a different room, and just using a fraction of the data for training to just fine-tune the model so that we can apply it in this case. So this is the work that I'm currently doing. And then my future plans are continuing on the working on scalability of machine learning solutions in buildings. So basically we know that every building is a bit different. They have a different amount of variables that they measure, the sensors measure. So we cannot apply them directly. So I will try to use technologies such as semantic web or ontologies to make that data more understandable for machines, and also to try to break silos, as I said, to use different kind of BMS, IoT, and different kind of data sources in the end to get a healthy, occupied, and high-performing office buildings using these technologies. Thank you.
Thank you, Davor. That
Thank
was
you.
interesting. How is it? I mean, most of the technology needed for sensing the buildings. Why is this kind of technology of yours not applied more? What is the problem in having smarter buildings?
So thing is that there's usually many different stakeholders involved when it comes to buildings. Like different company provides different kind of sensors, or other company builds the building, then there's architects and many different stakeholders.
Okay.
So it's not a typical product. And that is a reason that this data is not so much, it's basically in silos. And then another thing is that also that how technology is developing. Machine learning is still very new technology, and there's probably some other use cases that are more quicker to be implemented than this because of this problem of buildings. Then again, every building is different, so it's not, you cannot just scale things from one building to 1,000 buildings, just like that. So,
if you have developed your way of machine learning, how big effort is it to have a completely new building where you want to again apply and teach your machine? How big effort is it?
Yeah, that's a good question. So most of the current work is still in research. Many research articles are focusing on one building, one laboratory in a university where they tested something. But there's not much work done on this scale. So it's still not yet kind of a technology on a market that you can buy it. And that's what I'm trying to do here. Exactly.
You have to tailor it for each case.
Yeah.
Well, I wish you good luck.
Yeah.
And thank you for being part of us.
Yeah. Thank you.